Okay, let's go, let's go. A little late, but not quite deadline yet. Fruits into baskets 3. You're given 2 integer arrays, fruits and baskets of each of length n, where fruits of I represents the quantity of the ith fruit, and basket j represents the capacity of the jth fruit. Uh-oh. From left to right, place the fruits according to the following rules. Each fruit type must be placed in the leftmost available basket with capacity greater than or equal to the quantity of that fruit. Each basket can hold one fruit type of fruit. If a fruit cannot be placed in any basket and remains placed, return the number of fruit types that remain unplaced after all possible. Oh shucks, this is the same as yesterday, but the optimized version of it. Oh boy. It's 10 to the 5th, so yesterday's deal, which was n squared, was not good enough. Okay. Okay, so let's think about this. 4, 2, 5. So 4 goes into the 5, 2 goes into the 3, 5 goes into nothing. Okay. Well, I was kind of worried that this was going to be the problem when I did it yesterday, that the solution I had wasn't optimized enough. Okay. 4 goes into the 5, 2 goes into the 3. So you assign 4 into the first thing bigger than or equal to the 4. And then you assign the 2 to the first thing bigger than or equal to the 2 after the previous assignment has taken place. So what if you sorting it doesn't work. It's something like a heap or a stack. So let's really think about this. 4, 4, 2, 5, 3, 5, 4. So what could you do here? So you're assigning 4 to a basket. So you iterate over the baskets. 3, 5. 5 has to be assigned to the 4. But how do you keep track of 3? Because it could be like something like, it could be 1, 2, 3, in which case the 2 goes backwards 2. Or it could be 1, 2, or 1, 3, 2. When you skip over baskets, you need to know when you skip over baskets, So if you have a 3 as the first basket that you encounter when you're trying to do 4, that 3 will go to the first number after the 4 that is less than or equal to 3. So that would go to 2. So maybe if you what would that mean? 4, 2, 5. Is it possible to place a hold on the 4? Like if you see a 3, you hold off on assigning the 4, and you go down until you see something that is less than or equal to the 3. How do you know how many things are less than or equal to the 3? How do you know how many things are less than or equal to the 3? It's almost the same difficulty of the problem as how you know like how many things are bigger than or equal to the 4, I guess. Something similar. 4 goes to the first number that's bigger than or equal to 4. First number that's bigger than or equal to 4. Range of fruit values. I wonder if it makes sense to reassign things based on their rank. Reassign things based on their rank. Because the numbers here are kind of arbitrary. It's just the sizing of the numbers compared to other numbers. So the numbers here are basically 2, 3, 4, 5 is the range of values. If I remap it to 1, 2, 3, 4, then it would be something like 4, 2, 5 becomes 3, 1, 4 pi, and the 3, 5, 4 remaps to 2, 4, 3. So it's still going to give you the same, like a fruit that was going to previously go into a certain basket can still be going to that same basket equivalently. So like 4 goes into the second or third basket here, and 3 goes into the second or third basket. The benefit of doing that would be the values are densed. Values can be guaranteed to be 1 through 10 to the 5th at most. So you can do a hard-coded distribution somehow. A hard-coded array where the index of the array is the value. Would that help though? Okay, so if I remap here, like if I remap, wonder I think I might be able to remap based on strictly the values in fruits rather than the values in fruits and baskets. So, for instance, 4, 2, 5. For instance, 4, 2, 5 is going to remap to just 1, 2, and 3. And then 3 being, let's go 2, 4, 5 remaps to 1, 2, 3. And anything that is a basket value that is not identical to a fruit value just gets floored to the lowest fruit value that still is smaller than it, less than or equal to it. So 3 maps to 2, so 3 becomes a 1. 5 stays 5, so 5 is 3. And 4, so like 3, 4, 5 is like that. So this is the fruits remap. This is the fruits. This is the remap for the fruits, and this is the baskets. So 3 remaps to 1, 2 remaps to 1. Okay, so at that point, the benefit there is every number for the fruits is a unique value, kind of. So if you know that 2 appears in the remaps for the fruit, that's because there are some values that are smaller than it, and there are some values that are bigger than it. Assuming 2 is not the smallest, not the size of the fruits remap. Still though, I'm not sure if this gets me anywhere. Huh. So post remap 425 becomes 213. 354 becomes 132. Interesting, interesting, interesting. So if I see 2, in the fruits, that means that it needs to remap to a basket that is 2 or higher. So like that. And then if I see 1 in the fruits, that remaps to something that is 1 or higher. See 3 in the fruits, that maps to something that's 3 or higher. Okay, okay. Is there some way for me to... Okay, so what logically applies here? If you deal with the highest fruit, let's say the biggest fruit was like 100, that means that it needs to go to a basket that's that high or more. It needs to go to a basket that is that high or more. Which might be a very small number of baskets. Three. 100 fruit needs to go to 100 basket, or 101 basket, 102 basket. I could keep track of the number of baskets that are bigger than each value. So for instance, 1, 2, 3, there are 1 baskets bigger than 1. No, sorry, 3 baskets bigger than 1. 2 baskets bigger than 2. Bigger than or equal to. 1 basket bigger than or equal to 3. I could decrement that count whenever I remove a basket. But that's not quite right. Like if I remove 2, or remove, yeah, let's say I remove 2. And technically, I would need to decrement the 1 and the 2. There are now 2 baskets bigger than 1 and 1 basket bigger than 2. So decrementing doesn't necessarily work with the counts I'm thinking of. Okay. One, two, three, 4, 2, 5. Question is whether or not the remapping is any good. Why not? It's just a extra bit of complexity that doesn't necessarily improve any sort of algorithm allocation method. 4, 2, 5. Four, 2, 5. First number bigger than 4. Or 2, 1, 3. First number bigger than 2. Bigger than or equal to 2. For each number link it to the first index where that number or number bigger than that exists. Huh. For each number, link it to the first number where that or bigger number exists. Could that work? What happens when you remove a number in that case? So 2 links up to the first number where 2 is found within the baskets or bigger number than 2. So you can work backwards. So for each index, find where the first of that number exists or a bigger number for each fruit value. So you start off with the biggest one. Start off with the biggest one. So you find where 3 is. And then you say, and then you look at where the 2's are. And you say, the number that's 2 or more is either going to be where the first 2 is found or where the first 3 or more is found. And then for 1, say that where the first 1 is found is where or you find where there's a basket capacity of 1 is where the first one is found, or 1 or 2 or bigger. And then when you remove an element, then what happens? Let's say you remove a 3. Then that should change the 2 and the 1 as well. And the first 3, if you remove it, then you can say where 3 or more is found changes. Then that could also change where the first 2 or more is found. First 3 or more. So let's say my basket sizes were like 1, 3, 2, 3, 1, 1, 2. So, and let's say those indices were 0, 1, 2, 3, 4, 5, 6. So 1 or more, 2 or more, 3 or more. So the first 3 or more is going to be at 1. The first 2 or more is going to be, the first 2 is at 2. So it's going to be at 1.